Hey there, welcome back again. Video lecture 13. Uh, Good news, we've passed the halfway point of video lectures. That's great. We're on module 4B. Today, we're going to talk really briefly about scientific notation. And then, yeah, that's it. That's all we got for today. Pretty cool. So yeah, in your topics this week, we're looking for stuff about scientific notation. It's going to build off our exponent stuff from last time, which is really nice. Main thing to think about, and I'm sure you've dealt with scientific notation. If you're taking a science class now, you're probably dealing with it as well, navigating it. What I want you to think about is what scientific notation is it's trying to make you write less, essentially. It's this way of shorthand writing numbers. It's a way of writing really big numbers and small numbers. And taking a little bit less time to write those numbers, okay? So the main thing that we need to know is that to write something in scientific notation has a specific format, okay? So again, in your notes, right, you've got section 2, you've got section 3. Big takeaway here for section 3 is the format for scientific notation. To write something successfully in scientific notation, the way we're going to write it is we need to have a number from 1 to 10. So we'll get to here in a second. So this is going to be a number 1 through 10 times 10 to some power. I'm going to write an x, okay? So for example, if I wrote 8.36 times 10 to the 6th power, okay? This would be written in scientific notation because this first number, 8.36, that is between 1 and 10, times, we use a base of 10, right? 10 is this number that kind of suggests particular decimal points. Place value is by multiples of 10. So times 10 6 times, so 10 times 10 times 10 times 10, okay? So that's an example. What I want to build off of is stuff that we talked about last time. If we have, right, I want to focus on this second part, this times 10 to the 6th power. So if we had 10 and it's any positive number, right, a positive exponent, for example, a 6, is that 6 going to produce a big number or a small number? We're multiplying by 10 6 times. Positive exponents mean repeated multiplication. So anytime you have a positive exponent, you're going to end up with a big number. And this can go the other direction as well, right? If you're trying to take a big number and write it in scientific notation, that means you should have a positive exponent, okay? So often when people are doing this, you get so caught up on like, do I need to move the decimal place left and right? I want you to focus on, is that exponent positive? If it's positive, that means let's create a big number. Or if I have a big number, I need a positive exponent, okay? And then similarly, if I have something to a negative exponent, okay, negative exponents mean repeated division. So if I have a negative exponent, I'm going to be dividing by 10 several times. Dividing by 10 several times, that will create a very small number. The opposite is true. If I have a small number, I need to write negative exponent in my scientific notation, okay? Really big takeaway there. I think it makes it so much more seamless, builds off of what we already done, okay? So let's try a couple. You're going to be asked to go both ways here. So can you take scientific notation, go to standard? Can you go standard to scientific? So I've got two examples here. Let's start out with writing in scientific notation. Let's write 5,370 in scientific notation, okay? So what I would love to ask you first is this a big number or a small number, right? This is a big number. It is bigger than 10, so it classifies as this big number, okay? So our answer should have a positive exponent, so we already know that. I'm just going to write positive, but I'm going to erase that with a specific number here in a moment, okay? But we definitely want a positive. So now format-wise, we need to create a number that is between 1 and 10. And the way that we do that is currently our decimal place is right there, right? 5,370.0. Just note, just trying to save time, we don't write the 0.0, whatever, okay? So we need to move this decimal place until we get it to a spot where it's created a number between 1 and 10. So if I start moving it, I move it once, that is 537 now. I move it again, it is 53.7, still not between 1 and 10. I move it again, that is 5.370, okay? So the decimal place needs to go right there. So that's going to be the beginning of my scientific notation. 5.370 times 10. And now we know this is going to be a positive number. We just need to figure out what number it is. And the way we figure that out is how many digits did we move? How many places did we move the decimal place? We moved it once, twice, 3 times. So this should be a 3. Okay. Let's try it again. We have a decimal over here, 0.000538. Is that a small number? Big number? It's a small number. So our answer should be 10 to a negative exponent. We want to create a small number. Okay. Let's move this decimal place until we arrive at a number between 1 and 10. We move it once, still not between 1 and 10. Twice, nope. 3 times, nope. 4 times, when we put it here, we get 5.38. So that's what we're going to write, 5.38. And we just said it. We moved it 1, 2, 3, 4 times, and we moved it to create, it was a small number, so we need a negative 4. Okay. All right, let's try it the other way. If I have something in scientific notation, can I write it in standard notation? So we have something that is 1 through 10. We need to consider how we should move the decimal place. Should we be creating a big number? Should we be creating a small number? So the first one, we got 7.443 times 10 to the negative 6th. Negative 6 exponent means we're going to create a small number. We're going to be dividing by 10 several times. So I'm going to take 7.443. I need to move it so that it creates a small number, and I need to move it 6 times. To create a small number, should I move left or right? Should move left. So once I've run out of numbers, so I got to start putting zeros in. So that's twice, 3 times, 4 times, 5 times, 6 times. The decimal place should go right there. Let's check it. Once, twice, 3, 4, 5, 6 times. That is my final answer. I'm going to rewrite it so it's nice. 0, 0, 0, 0, 0, 2, 4, 5 zeros, and then 7, 4, 4, 3. Cool. All right. Similarly, 10 to the 7th, it's a positive exponent. That means we're multiplying by 10 7 times. That will create a pretty large number. 4.33. Let's move it 7 times. Should we move it to the left or to the right? Let's move it to the right because we're creating a large number. 1, 2, 3, 4, 5, 6, 7. Okay. The decimal place should end up here. In my final answer, do I need to write that decimal place? No. Just copy down however many zeros you need to. You can put commas there if you want. That's 43,300,000. All right. Make sure you go to your Alex and practice this. This is our only video for video lecture. What are we? 13? Cool. So for class, this is what I need you to do. Pick your own very large or very small number. So this can be any number that you pick, whatever it happens to be, it doesn't matter. It could come from your prospective field. It could be one that you're interested in. If you want to know how many predicted planets there are in the Milky Way galaxy, Google that, use that as your number. I want you to write your number that you've picked in both standard and scientific notation. Bring it to class for us, all right? All right, great job again. Proud of you for clicking on this and doing the right thing. Take care. Let us know if you need anything. All right, I'll see you next time.